Is it recording? Oh, yeah. Okay, today we're going to look at zeros of polynomials, and it's going to involve polynomial division. And what I'm showing up here is some long division that you would have seen in your first algebra class. Usually the way algebra classes are set up, you do adding and subtracting where you're combining like terms, and then foiling, that's where you multiply polynomials, and then the messy stuff is this polynomial long division, which we're not going to be doing today. We're going to see a shortcut method for dividing polynomials, and before we do that, maybe I better get some terminology for us. When you're dealing with division, there's three symbols for writing division. One is just the long division symbol. And if you have a long division symbol, the stuff that's under the division symbol is called the dividend. And over here is the divisor. And the answer to a division problem, which goes up here, that's called a quotient. And sometimes you might have a remainder. See, you have dividend, divisor, quotient, remainder. Another way you might see a division written is with a fraction bar. And if it's written like that, then the dividend is on top and the divisor on the bottom. And there's still one other way. The little thing.
Wait, say equals quotient.
Oh, okay, equals quotient. Quotient is the answer for a division problem. And one other way you might see division written is with the dividend, that symbol, divisor, equals quotient. Okay, so dividend and divisor. Look back at the long division problem. That first stuff here, the 5x to the 4th plus x to the 3rd and all of that, that's the dividend. The divisor is x minus 1. The quotient would be that stuff up on top, the 5x to the 3rd plus 6x squared plus 3x minus 1. And then the remainder is that red negative 11.
And notice there's two different ways of expressing the quotient when you have a remainder. You write out the quotient and then just comma, remainder is negative 11.
I would have preferred if they wrote R equals. That's what I like to do.
That's what I do. Or the quotient plus remainder over divisor. So negative 11 was the remainder over the divisor. Just like 7 divided by 2 is 3 1/2. Remainder over the divisor. So
the way we'll see it primarily, I think, is just with the R, remainder equals negative 11. And I do think they should have had an equals there. But we're not going to be doing long division. We can use something called
synthetic division. You know what might be fun, Tony?
What?
If you use synthetic division on this actual problem to show them.
Yeah.
Okay.
You can use something called synthetic division when the divisor.
Wait. So you're writing one of your sentences.
Is in the form x minus k.
I always say plus minus k.
Oh, well. And I will just show you how to go through the steps of synthetic division. It's not difficult, but actually writing out step 1, step 2, step 3 without seeing an example, now that's kind of involved. So let me write down this first problem we're going to do. All I'm going to do is rework that problem we're showing using synthetic division rather than long division. Again, if you don't remember how to do long division, that's fine. I'm
have
showing you that just because that's not what we're going to be doing. Okay?
And the shortcut is so much better than all of this stuff here. You'll see
So
that
let
in a
me
moment.
see.
5x to the 4th plus x cubed minus 3x squared minus 6x minus 8. That's the dividend. And we're going to divide it by, the divisor is x minus 1.
So, is the divisor in the form x minus k? Well, yeah. X minus k, notice I have it in red, just like the 1. The k value is 1 here, and that's going to be significant on how I set these up. I'll start off.
But one thing I like to, a note I like to make is that k is exactly the opposite of what you see inside the parentheses. You see a minus 1, so the k value is a positive 1. If this were an x plus 1, your k value would be a negative 1. The k value is the opposite of what you see there in the divisor. Okay, so
I will start with the synthetic division. It's going to take 3 lines of paper, 3 lines on your notebook paper. If you're using lined papers, it's going to be 1, 2, 3. You start off by drawing a backwards L, and then I'm going to write in it k equals, the k value here is a 1. If we had been dividing by x minus 3, the k would be 3. If we had been dividing by x minus 9, the k would be 9. Then going straight across, you're going to write just the coefficients of the dividend. Don't put the variables. All you're putting are the numbers. Don't forget that right here on x to the 3rd, there's a coefficient of 1 there. So I'm going to write it like this. 5, 1, negative 3, negative 6, negative 8. I'm going to draw what looks like an equal line right here. And to get started, that's how you set it up. Again, it's going to take 3 lines of paper, 3 lines on your notebook paper. And you just sort of follow this pattern I'm showing. Take the first number that's right here in the dividend, 5, carry it down below the line. This spot right here stays blank. Every number you put below the line, you multiply by k. So I'll say 5 times 1, and I'll put it right here.
I would put the plus sign there to make a note. That's a positive 5. And then that tells you what to do to the next column. What do you see? 1 plus 5 gives you a positive 6.
Then continue. The numbers down here, you multiply by k. 6 times 1 is 6. It's a positive 6. So negative 3 plus 6, what number am I going to put right here?
Once again, I would have put the plus there because it's a positive 3 and then a positive 6. Because then I go through and I sweep across with the variables at the end. I have the whole answer there. I don't have to rewrite anything.
Oh, well, I usually put those pluses at the end. But okay. 3 times 1 is 3. Negative 6 plus 3, negative 3. Negative 3 times 1, negative 3. Negative 8 minus 3. What's this number going to be right here? It's a negative 11. And at this point, the answer's staring you in the face.
You're taking x to the 4th, and it's being divided by x. Just think of x to the 4th over x. You could cancel 1x above and below. What power of x would you have remaining?
x to the fourth divided by x. You cancel one of the x's.
Write it out.
Oh,
X to the third. That's going to be the pattern. Whatever the biggest exponent is in the dividend, the quotient will start with the next power 1 less than that. Since that was an x to the fourth, you start with the next third, and then sweep across, decreasing the powers. X cubed, x squared, x to the first, no x, and that negative 11 is the remainder.
This last number here is always the remainder. The number right before it is the constant. The constant doesn't have an x on it.
Let's see, where's that little picture?
Let's look and see how the answers are.
Let's look and see.
I claim that we have the answer right here on a sheet of paper.
5x cubed, is that what we had?
Look at it.
Plus, oh, there it is, plus 6x squared, plus 3x, minus 3, with a remainder of negative 11. Is that what we got?
Mm-hmm.
Let's look. Yeah, I think that's what we got using synthetic division, and it is so much quicker.
Okay. So you start off by identifying what k is. The divisor has to be in the form x minus a number. If it's x plus, we can get around it and work with that, and I'll show that in a moment. But you got to sort of do a couple of these to get that pattern.
Oh, we never even logged into my lab?
Oh, wow. Okay. Logging in.
Did y'all start recording?
Yes, we're recording.
In fact, while you log, oh, okay. I was going to say pause it, but
And then it
okay.
freezes.
And it doesn't do that for now.
Okay, here we are. This is Monday, Wednesday. Under assignments. And zeros of polynomials.
Continue. Okay.
And let's look at number...
No, not number. Oh, I was going to say 4 is the best one to start.
Okay.
Okay, so here's our first example. The first 4 problems are just do synthetic division. And let me write down number 4. 5x to the fourth. Oh, watch it be exactly the one we just did.
No, it isn't.
Couldn't be. Oh, okay.
Minus 14x cubed plus 11x squared minus 7x plus 2. You divide it by x minus 2.
So the divisor is in the form x minus k.
Make sure that
Did it miscopy it?
yeah, not on it.
Okay. Oh, let me lift up. So the divisor is in the form x minus k, and here k is 2. It's the opposite of negative 2. It's positive 2. So I'll draw my little backwards L and write k equals 2.
This problem, even though it sort of looks like that example he just did up here, it'll have more interesting numbers popping up, because in this previous example, he was just multiplying by 1, which didn't change anything. You were just bringing the numbers that were down there below the line up to the second space. Here you're multiplying by 2, so there's going to be some changing in the coefficients.
Start by bringing the first number down. It's just a coincidence that both of these have a 5. Both of the example I did there and here both have 5. Now you'll see what he means. His numbers are going to change more because we're multiplying by 2. 5 times 2 is 10. Negative 14 plus 10, that's a positive 10, right? Negative 14 plus 10 is negative 4. Negative 4 times 2 is negative 8. 11 minus 8 is a positive 3.
What's going to go here underneath this negative 7? You take the positive 3 and do what?
Multiply
Multiply by 2 to give you a
is
positive 6.
So negative 7 plus 6 is negative 1.
So negative 2 will go here. Negative 1 times 2 gives us a negative 2.
What's our remainder going to be here? 0, yeah. Now to get the variables,
What variable is going to be beside this 5 right here? Well, the variable is going to be x. What power is going to be on that x?
3.
Okay,
You subtract
once
1
again,
from the big exponent.
So x cubed.
Cubed x squared x.
Hey, what was our remainder?
0. I'd already asked that.
You had that
Mhm.
one.
Yeah. And so we'll type in 5x to the third minus 4x squared plus 3x minus 1 as our answer here.
Let me make sure I have time to write that down. Okay, I'm going to type it in now. So we have a 5x cube minus 4x square, get out of the exponent, plus 3x minus 1. Oh, I can't find it. There it is. Any questions there?
Nice little way of
How about number 3?
let's do number 3. I think the problems 1, 2, and 3 are multiple choice, and so I sort of wanted to the
I like
first
this
one to be.
though.
Yeah, I know. So let me write down number 3.
I'll do this one.
Okay. Okay. So our dividend,
Let's move that chair.
is 4b like boy, so 4b cubed plus 13b squared, I'm just writing the problem down, plus 9b minus 5, and our divisor is b plus 2. Okay, let's switch over. Oh, wow. I'd said that the divisor had to be in the form x minus, or, well, I guess in this case, b minus, and this is a b plus 2.
But it falls out very nicely. Realize b plus 2. Don't write down what I'm about to write down, but that's the same thing. Isn't a double negative the same thing as a positive? You could have b minus a negative 2. So in that event, the k value is negative 2. Remember what I said. The k value is exactly the opposite of the number you see inside the parentheses. So when the divisor has a plus instead of a minus, it's no big deal. You see a plus 2, the k value will be a minus 2. So I make my little hook. Oh, hook. Okay. That was one of the things about Friday's class. The student argued that wasn't a backwards L, it was a... Oh, okay, so I won't call it a backwards L for the rest of the class. But L's don't have such a long horizontal part. Okay, so then we start off with the biggest exponent. That coefficient is 4, so we have a b cubed, the coefficient of b squared, the coefficient of b to the first, and what's my constant? What number am I going to put right here? Negative 5, correct. I bet y'all are so excited to know that what Houston's working on in the future, you're not just typing the answers, you'll be typing in all the little numbers in the blocks as you go through and stuff. They've already done that for a lot of trigonometry. Oh, wow. So what do we do to get started? Oh, I should have asked you this. When you saw the problem, you knew what variable part your quotient would start with. What will it start with? You're right, the coefficient's going to be a 4. But what about the variable part? We're going to have a b 2. I agree. It's 1 less than that. And you've made a good point that the coefficient of the quotient, the leading coefficient of the quotient, will always be the same number you start off with, because when using synthetic division, you're just dividing by that variable there. You're not dividing by a 3b or something. So we take the positive 4 times negative 2. That gives me a negative 8. 13 minus 8 gives me a positive 5. And then you take the 5 times negative 2. That gives us a negative 10. 9 minus 10 gives me a negative 1. Negative 1 times negative 2 gives me a... In the previous problem, we had a remainder of 0. What's going to be our remainder here? Negative 3. Negative 5 plus 2 is negative 3. So the quotient starts off with the b square as its leading term. So we have a 4b squared plus 5b to the first minus 1. The remainder is negative 3.
And you've got to be careful. These multiple choice problems I discovered on Thursday, they all look the same, at least the answers. Okay, which one is it?
Not A. I thought it was A, but it isn't. I think it's B, isn't it?
Is it B? 4b squared plus 5b? No, it isn't. That's
Yes,
a plus
it is.
1.
It's, oh, wait a minute.
It's C.
No,
it
the
isn't.
remainder is a negative.
It's D. Oh, wow.
Oh,
Is it
goodness.
D?
Yeah, it's D. Oh, I was ready to jump on that B bandwagon, and I would have gotten it wrong. With the multiple choice question, if there are 4 options, you have 2 opportunities to choose the correct answer. If you don't get it correct, then you have to say similar question, get us another question, and redo the problem to get credit. Any questions there? Okay. Tell me you want to start writing?
Okay. On number 5, we're going to use something called the remainder theorem. So let me write this down before we actually start doing
Write down
anything.
the remainder theorem first.
The remainder theorem. Oh, I thought I turned mine off. The remainder theorem says if you have a polynomial and you plug some number k into it, the value that you're going to get is the remainder if you used k and did synthetic division. It's sort of a shocking statement that we present without a lick of proof, just to illustrate it.
But we can show. Let's take number 3 here, and let's take that. No, I said B. I meant to write k equals.
Oh, yes.
Let's take that k value. Let's take the k value of negative 2 and plug it into 4b cubed plus 13b squared plus 9b minus 5. I have my calculator right here. I thought.
Y'all don't. It's right there.
Yeah.
Leave it.
Okay. So don't bother writing this down or anything. Let's just see. If we take negative 2 and we plug it into 4b cubed plus 13b squared plus 9b minus 5, what are we going to get? 4. Replace the b with, move your finger.
Negative 2.
Negative 2. And we want that cube.
Notice how I use that little arrow or caret top to enter an exponent?
Yeah, I use that almost exclusively. I don't even use
I
the
use
square.
the square when I can.
No, I always use the caret top.
Plus 13.
Plus 13 times negative 2 squared plus 9 times negative 2 minus 5. What do y'all think that's going to give us?
The remainder theorem says we should get what the remainder is.
What was the remainder?
Negative
3. And look at that. We got a negative 3. Back in the olden days, that remainder theorem is actually very significant. Before calculators, say you wanted to take let's say 81. You wanted to plug in 81 for all of those b's. Then that was an ordeal, figuring out 81 cubed, then times 4. Before calculators, that would have taken you quite a bit of time. But notice with synthetic division, there's no exponentiation. All you do is you just multiply, add, and subtract. And that number down there is the value of the expression. So the remainder theorem was important years and years ago when there wasn't an easy way to perform this large exponentiation.
If you get one of the older, like a TI-85 calculator has a little function called polynomial, and you can punch in the polynomial and then evaluate the polynomial, plug numbers in, and what it's doing is actually, it's programmed to go through the synthetic division, I believe, rather than trying to cube the big numbers and so forth. But looking at number 5.
Wait, let me get to number 5. There, and let me hide there.
One thing you could do to find f of negative 3 is just to plug negative 3 in for x. Isn't that what we were doing when we were told to find f of negative 3 on the first assignment over functions? But on this one it says don't do that. Do it with synthetic division instead.
Now on a test, you're taking the test and they're asking you to find f of negative 3. Am I going to know if you use synthetic division? No. And I'll be honest, if I had a function and I needed to find the value of a function at a number, I'd pull out that calculator and just do it like that. So I can't blame you if that's what you did on a test. But it is still interesting, and there's some historic applications for the remainder theorem, namely the way it enabled people to evaluate functions without having to use those big exponents. So there was, prior to calculators, there was a lot of this. And I recall looking at a business calculus book from the 50s, and they were doing synthetic division everywhere. Whenever they had to evaluate a cost function or a profit function, what is this? Well, they were using synthetic division.
Because they didn't have calculators.
Because they didn't have calculators. Oh, people refer to those days as the good old days. Oh, God, I don't know.
I think good old days are only when you're young.
Yeah.
Okay. I've written down my k equals negative 3 and negative 2, negative 8, negative 6, negative 5. And now, it just dawned on me. I kept thinking a color was missing. Carry down the negative 2. And negative 2 times negative 6.
Oh, question.
Excuse me. No. Oh. No, it only changes if they don't just tell you k equals.
Okay, it only changes short the way it was.
Like here, it didn't tell you k equals. That's when you have to change the sign. If it gives you the k value, you don't have to change it. Okay?
But if you're going to go backwards, that's a good question, because we're going to be taking the k value, and in a moment we'll have to go back to the divisor. Suppose they give you the k value, and you have to go back to the divisor. The sign inside the parentheses, the divisor always starts off with the variable, but the sign is exactly the opposite of the k value. So when you're going backwards, like here, the k value is 2. The divisor was a minus 2, an x minus 2. That is a very good question, and I'm glad you pointed that out.
I should have mentioned that.
When I give you the k value, that's exactly what you use.
Yeah, you don't have to change it. Since I said k equals. Okay, so negative 2 times negative 3, that's a positive 6. Negative 8 plus 6, another negative 2.
What's going to go here?
2, times negative 3. Is that going to be a 6? And then negative 6 plus 6 is 0. 0 times negative 3 is 0.
So what's our remainder going to be?
Negative 5
5?
Yes.
That means if you had plugged a negative 3 in here for all of these x's, if you went through and replaced those x's with a negative 3, what would you expect to get? Negative 5.
Mm-hmm.
So write it out. F of negative 3 equals negative 5.
And again, and today, if you want to just punch it into your calculator, fine.
That's what I do. I'm sorry.
But if you didn't have a calculator, if instead of negative 3, if it had said negative 30,
31. For cubing, squaring, and multiplying. So we come over here, and we're going to type in a negative 5. Any questions there? And
now I want to switch it back over here. I need to give some terminology.
Tony's defining the word 0.
K is a 0 means if you plug that K value in, you get 0. Or, in other words, the remainder is 0.
Division, the remainder has to be 0. But a 0 is a number you can plug into a function and make it equal 0.
Like in the previous problem, number 5, is this K value a 0? If we plug it in, do we get a remainder of 0? No. Let me see, I think we had one where we did get a remainder of 0 on problem 4.
Oh, look at it.
On problem 4, our remainder is 0. So if you wanted to impress someone, you could say K equals 2 is a 0 for the polynomial 5x to the 4th minus 14x cubed plus 11x squared minus 7x plus 2. Okay?
And go back to that definition, because I'm occasionally revert to old-timey lingo. They used to call this, instead of a 0, they would use the word root. K as a root means P of K equals 0. Well, if you hear the word root mathematically, you start thinking of what? Square roots and cube roots. Has nothing to do with that. So
that's why I've quit using that word.
I try not to, okay? But occasionally I still...
If you look in an old book, you'll find it.
Yeah.
Okay? I don't know how many of you go around the libraries looking in an old math book. Not half of you, I would think.
Sure.
I'm joking about that.
Okay.
So, what I'm about to do is going to seem off track, but we've done some stuff like this before. We've factored stuff like x squared minus 5x plus 6. How would we go about factoring that?
So trinomial, so I'd write my two sets of parentheses.
You'd go x and x. Second sign is plus, so 2 of the first. It's been a while since we've factored in here, isn't it?
For 6, you could have what? 1 times 6 or 2 times 3? Which one would you use? 2 times 3 to get that minus 5x there. I agree.
Now, let's go ahead and solve this equal to 0. If I set each one of these factors to 0, what's the first solution I'd get here? 2. What about this one right here? 3.
You have just found the zeros for the function defined by x squared minus 5x plus 6.
And you just discovered the factor theorem all on your own. The factor theorem says K is a 0 if x minus k is a factor. I'm going to break it up instead of saying if known if. It also says it the other way. X minus k is a factor if k is a 0. And you may be thinking, wait, that's not what I discovered all on my own. Yeah, it is.
Here are the factors. Okay, change sign. That minus 2, the 0 is a positive 2. Change sign, the minus 3 is a positive 3. But if we're going backwards, if you know the k values, that's a positive 2, so you have an x minus 2. That's a positive 3, so the factor would be x minus 3.
Do you see how those signs are changing? It's based on how we solve linear equations. And so far this semester, all we've factored is x squared. Okay, 3 terms with x squared. I suspect y'all have been wondering, what would we do if instead of an x squared, we had a x cubed? Instead of 3 terms, what if we had 4? And that's what we're going to be doing. Show number 6, just so they get an idea. On problem number 6, we're going to start factoring things that have 3 terms. 4x cubed plus 7x squared minus 34x plus 8. That's what we're going to try to factor. And in order to do that, we have to know one of those zeros. So if we know one of the zeros, it's pretty darn easy to factor it.
Using synthetic division.
Yes. And not using trial and error. Well, I'll use trial and error, I guess, in the quadratic part. But let me go ahead and sketch out how we're going to factor. How to factor a polynomial when a 0, which we call k, is given. Step 1, use synthetic division. Then once you do that,
and remember, if that k value is a 0, the remainder is going to be a 0. That means the quotient will be a polynomial without, that can be factored further if it's factorable, but there won't be a remainder.
X minus k is always a factor, just like up here, where 2 was a 0, x minus 2 is a factor. 3 was a 0, x minus 3 is a factor. And then your goal is going to be to get 3 sets of parentheses that you could start foiling out and eventually get back what you started with.
Now, if it were next to the 4th, you'd have 4 sets of parentheses. So you could say right here, repeat if you get something that that's not a quadratic. Okay, you're right. Factor the quotient.
So we're discussing how to factor something that's an x to the cube or an x to the 3rd, and maybe we better just do it because
it's not as bad as he's making it sound like it is.
So this is number 6. F of x equals, you want to call it out, Tim?
4x cubed plus 7x squared minus 34x plus 8, and the k value is, the 0 they'll give us is 2.
Mm-hmm.
While we're thinking of it, before we do anything else, what's the factor associated with this 0, k equals 2? It's going to be x, what?
Plus 2 or minus 2?
No. Minus 2. Remember, the factor is exactly the opposite of the k value. You see a positive 2, so the factor will be at x minus 2.
Oh, but then type that in.
Oh, I'm going to write that down right here. X minus 2. We're not through with the... Oh, x minus 2, yeah.
we're going to have 3 sets of parentheses in here. Just like when we're foiling, we have just 2 sets of parentheses and stuff.
When it's a quadratic, if it's factorable, there are 2 sets of parentheses. When it's a cubic, if they want it factored into linear factors, that means we're going to need 3 sets of parentheses.
And
Each
they're
one will
calling
have
them
an X
linear
in it.
because there's no exponents in it.
Right.
Okay? So
Let's go to the work page.
now here is where I write my k equals 2. Notice here I didn't change it. It's only when you're going from a k to an x term that the signs are changing. So we have 4, 7, negative 34, 8. Carry down the 4.
Okay, what goes here at the pointer? Oh, not 4.
Oh, wait.
Oh, there's 4.
4 times 2 right here. 8.
Down here.
That's 7 plus 8 is a positive 15.
What's going to go up here under the negative 34? I agree. 15 times 2, that's a positive 30. Down here, negative 34 plus 30, I agree. Here, 2 times negative 4 is negative 8. And look at that remainder. And that's not surprising. We were told that k equals 2 is a 0, so we expect the remainder to be 0.
So let's put in our variables and then factor. So it'd be x.
What exponent are we going to have here? Okay.
Then an x, and there's our constant. So what I'm doing right now, let me write this a little bit neater. To get your other 2 sets of parentheses, you're factoring that quotient. Oh gosh, let's see. Numbers that multiply together to give 2, 1 and 4, or 2 and 2, 1 and 4, 2 and 2.
You cannot use 2 and 2. I can see that in my head. If you try to use 2x times 2x, then you're always going to be pairing one of those 2's with another even number.
Do y'all
You
remember
either
that
pair the
rule
2
about?
with the 4, or you pair the 2 with another 2.
But there was that rule way back when we started factoring. We said you can't have common factors. Like it can't be a 2x and a 2x, because if so, you couldn't put the 2's here, and you couldn't put a 1 here.
No, 4.
I mean a 4. And so it's going to have to be
1x times 4.
4x.
Okay.
And 4 and 1? Is that what I heard? Like this?
What
Now,
about signs? It's
plus and minus like that? Yeah, that's right.
the outer product is a negative 1x plus the inner product 16x. Negative 1 plus 16 sure gives us a positive 15.
So, well, I guess we typed in x minus k first. But I said use synthetic division. X minus the given number k is one factor. The other 2 factors are
Move it down.
found using trial and error right here. Your goal is going to be 3 sets of parentheses. One of them is the x minus k, so x minus 2. Here they all are. If you started foiling it and multiplying it out
And combining like terms.
you'll get this 4x to the third
You can't
plus
see.
7x squared minus 34x plus 8. Now the order in which you type these parentheses doesn't matter.
But I'll always write the one that's associated with the k value first. That's the thing. As soon as I see the k value, I know one of the factors is x, change whatever this k is. So, and I've already typed that in. So let's type in the rest of the factors. You have an x minus 2 and an x plus 4 and
4x minus 1. And imagine if you could, trying to do this with trial and error would take a long, long, long time. Imagine trying to draw. I can't imagine that any of you have ever done the 3 sets of parentheses trial and error, because that takes a long time.
Now, I want to point out something to you. So, if this had been an x to the 4th or an x to the 5th, you would have started, okay, say that was an x to the 5th. You would have used a 0, that would have broken it down to an x to the 4th. You'd need another 0, that would break it down to an x to the cube, and then you still have to have another 0 to get it broken down further than this. So you can adopt this method for higher order polynomials, but there's a big, big weakness in this method. Has anyone figured out the big drawback to this method of factoring?
Suppose we hadn't been told k equals.
Suppose we didn't know a 0. If they hadn't told us, oh, you can plug in 2 here and make it equal 0, then we wouldn't have known how to get started.
How to do the synthetic division. You have to know that 0, and it turns out that's not hard to find.
Hey, you know something? What are the other zeros? We know 2 is a 0. We know 2 is a 0. Because if you set that equal to 0, x minus 2 would be 0, you know, when x is replaced with 2. What are the other 2 zeros of this function? When does x plus 4 equal 0? Negative 4. Okay, so you found another 0. When does 4x minus 1 equal to 0?
I'll give you a hint. This one's going to be a fraction.
1 over 4. So once you get that factored, you can find all the other zeros. But
oh, and how many zeros should there be? Look at the exponent.
There's something called the fundamental theorem of algebra that we really don't discuss much. People it's not taught much. As a matter of fact, student learning outcomes for this course that are mandated by the state never even mention the fundamental theorem of algebra. That sounds important. The fundamental theorem of algebra, and you're in an algebra course.
You would think you'd hear it.
Yeah.
Anyway.
The fundamental theorem of algebra says the number of rational solutions to this thing cannot be more than that exponent. It's an x cubed. You can't have more than 3 zeros.
And y'all know that with the x squared, flip it right back.
With an x squared,
you never get more than 2
solutions. You may only get one solution.
If
you could have x minus 2, x minus 2, but you can't have more than 2 solutions.
Let's do number 8.
Okay. Oh, goodness, Tony. I'm sort of sorry I missed the class on Thursday. I'm really enjoying this.
Okay. This one is a little different in that it doesn't say k equals.
They just tell you that negative 6 is a 0. So that's the k value, negative 6. Even though they're not using that notation, by knowing negative 6 is a 0, that means k is equal to negative 6.
Plus 6. And we're told negative 6 is a 0. That means k is equal to negative 6. You don't change the sign.
Make sure you don't miscopy.
Oh, okay.
They tell us, write that out. Negative 6 is a 0.
Oh, okay.
Write it out.
That's what it said instead of k equals. Like on problem 6, they actually said k equals 2 is a 0. But on number 8, they don't say k equals, but they tell you negative 6 is a 0, so that's your k value.
While we're thinking about it, what is the factor associated with that negative 6?
Yeah, we're going to have 3 sets of parentheses in our answer, so let's go ahead and get one of them already done.
X. What's going to go after the x? Plus 6, correct. It's exactly the opposite of your 0. It's the exact opposite of the k value. And if you think about it, if you plug in negative 6 here for x, what do you get? Negative 6 plus 6? That gives you 0. So, you know negative 6 has to make the expression equal 0. That's why it's exactly the opposite. Now, let's go on.
So we've already got one set of parentheses. We only need 2 more. So we'll do synthetic division and factor the quotient. Start off, bring down the 4. 4 times negative 6 is negative 24. 19 minus 24, is it going to be a negative 5?
What's going to go here? Where my mouse is. Y'all see where I'm pointing?
Oh,
what's going to go under the negative 29? 30, I agree. Negative 6 times negative 5. Down here. Negative 29 plus 30, that's a positive 1.
1.
Negative 6.
What are we getting as a remainder? It better be a 0, because we were told it was a 0. Okay?
So this one's going to be easy to factor, I think.
Oh, is it?
X to what power? Okay, good.
Oh, I had to put my plus. I like to write this now with just one color. So what we're trying to do now is factor 4x squared minus 5x plus 1. I'll draw my 2 sets of parentheses. Oh, I see what you mean by it being easier to factor. Second sign is plus, so 2 of the first. What times what will give 1? Yeah, okay.
We know those last terms have to be 1. So it's either 1x times 4x or
2 and 2.
2 and 2. So which one do you think we'll need? I think we're going to need 1x times 4x.
Now if we FOIL that out, we'd have 4x squared, then a minus 1x and a minus 4x. The outer and inner give me the minus 5x. Then negative 1 times negative 1, when we multiply the last 2 terms, that's a positive 1. So the thing that here are the 3 sets of parentheses. I'm going to go ahead and write down the x plus 6 that Tim had already typed in.
Any questions here before I switch over and type this in? Provided you know a 0, you can start using synthetic division. From the 0, you get one of the factors. Use synthetic division to get something that you can factor by trial and error using the factoring methods that we saw at the beginning of the semester. And if you didn't trust us, you could just sit here, FOIL out that x plus 6 times x minus 1, combine like terms, then distribute a 4x over everything, distribute a negative 1 over everything, combine like terms, you should get back 4x cubed plus 19x squared minus 29x plus 6. Okay, let's type that in.
So x minus 1, 4x minus 1.
This is a powerful method for factoring polynomials of a higher degree, a higher order. But the drawback is you must know a number that can be plugged in to make it equal 0. You have to know a 0 in order to use this factoring method.
So
number.
How do we find those zeros? Okay. Let me write down.
Hold on.
Okay. Possible rational zeros. This is going to be a way for you to figure out which numbers could possibly be zeros.
If you were, go back to this one here. If they hadn't told us that -6 was a zero, and we just had to start trying, well, just maybe 5 makes it equal 0. Maybe 1, well, in this case we would have been okay, but
if you just had to guess and try to find zeros.
Trying to find a zero, suppose you need to factor something, and they didn't give you a 0. Well, what number could be a possible 0? You have to find one. What Tony's about to write down is called the rational zeros theorem, and then it's going to give you a finite list of numbers that could possibly be 0. So if they hadn't told you the 0, you'd go through this little test, and you get a list of about 20 numbers that might be zeros. And you just get started. Okay, check the first one. Is it a 0? If so, use synthetic division. If not, go on to the next one. But the purpose of this is it gives us a finite list of numbers that could possibly be 0. So at least you have a starting point. At least you know, okay, I can start here. See which ones of these would equal 0. Possible rational zeros must be in the form, the numerator has to be a factor of the constant term. The denominator has to be a factor of the leading coefficient.
By the constant term, we mean the last number in the polynomial.
The thing that doesn't have an x.
And leading, what do you think leading means? Well, the first number. And you're thinking, oh, well, you're saying it's not that bad, but it sounds bad. No, trust us.
You know what I think would be fun? I'm going to take that question that we just did.
Oh.
I'm going to take this question that we just did and find all the numbers that could all the possible rational zeros.
Okay. Here, write it out. What you're going to do.
I'm going to find.
Let me write this down. Realize we've already found the possible rational zeros. We've already found the zeros basically for this 4x cubed plus 19x squared minus 29x plus 6. We can look here. The first factor is equal to 0 at -6. That was a 0. Another 0 is, when is x minus 1 equal to 0? Oh, y'all don't see what I'm pointing at because Tony's not pointing at it. There. When is x minus 1 equal to 0? By positive 1, so there's another 0. And what about this one? When is 4x minus 1 equal to 0? At 1 over 4. So we know -6, 1, and 1/4 are the zeros. But suppose they hadn't given us that -6. Suppose we didn't have any idea what to use as a 0. So let's switch over here. We're going to find the possible rational zeros. They're positive or negative. Oh, I guess you have it written right up there, don't you?
Yeah.
Factor of the constant term. So I'm going to say, I'll write it out again. That's okay, don't worry.
Constant term is that last number, so 6.
No, you're right. The constant term, 6. What are we going to have the factors of here? 4.
That first number. So let's write them out.
The factors of 6. 1 times 6 and 2 times 3. You say, well, -2 times -3 gives you a positive 6. The plus minus here is going to take care of all those sign changes, so you only have to worry about the positive factors of 6.
Now we need the positive factors of 4. There's 1 times 4 and 2 times 2. I have to write 2 down twice. So you take every number here on top, put it over 1. Take every number on top, put it over 2. Take every number on top and put it over 4. You have to look at every possible combination. So here we go. Plus or minus. We have the little plus minus. We're going to put them all over 1. So 1, 2, 3, 6. We put over 1. Then we take the 1, 2, 3, 6. What do we have to put them over? 2. Okay, so now we're going to put them all over 2. So 1, 2, 3, 6. Now we have to take all those 4 numbers on top, 1, 2, 3, 6, and put them over 4. And then we're going to have to clean up all of this. So we have 1, 2, 3, 6. Pardon me? Oh, the commas. Yeah, I forgot about my commas. So now we're going to clean up all of this. The first row is easy. The things are all over 1. So 1 over 1, that's 1. 2 over 1 is 2. 3 over 1 and 6 over 1. So here's the final answer. My possible rational zeros. Notice the little notation I'm using. PRZ for possible rational zeros. We have plus or minus 1, 2, 3.
1 is 3, 6 over 1 is 6.
So we took care of these 4. The next one, 1 over 2, that's 1/2. Took care of that. Hey, what's 2 divided by 2? That's 1. Don't we already have 1 listed? So we can mark that one out. 3 over 2, that's 3/2. We don't already have it listed, so I'll add it to my list. Okay. What about 6 divided by 2? 3. I think we already have it listed, don't we? So we can mark out that 6 over 2. 1 divided by 4, that's 1/4. We don't have it listed already, so I'll write it down. 2 divided by 4. 2 divided by 4 is? Isn't it 1/2?
4 over 2 is 2.
Oh yeah, 4 divided, that they're saying 4 divided by 2 is 2. 2 over 4 is 1/2.
What number is the smaller one? It's going to be a fraction. And so it's 1/2. And it's listed.
3 over
Even
4.
if you said it was 2 and you didn't list it, you've done it right.
Right. Uh-huh. 3 over 4, that can't be reduced and it's not already listed, so let's add it to our list. What about 6 divided by 4? We can cancel a 2 above and below. What does that give us? 3 over 2. Isn't that the one we... No, isn't that right there? I think we don't need that one. Here, all... These are the only numbers, the only rational numbers that you could possibly plug into this function and make it equal 0.
And we were told 6 is 1, and there it is.
There it is.
I think you said
1 and 1/4. There they are in the list.
So if you do this and someone asks you, is 5 a 0? No, 5 can't be a 0. It's not listed there. What about the number 8? If we plug 8 in there, would it give us a 0? Can't possibly.
It's not listed as a possible zero. So this list of possible zeros is very significant because now you know. Will negative 17 make this function equal 0? No, it's not in the list of possible rational zeros. Now let's do one of the homework problems. Okay.
It's multiple choice.
Oh, this is
Says find the possible rational zero.
Well, I like this one better. The numbers are...
Yeah, the numbers are smaller for these. 2x to the third.
2x to the third plus 9x squared plus 7x minus 8.
Now, it's going to look like I'm not even looking at the 9x squared and the 7x.
That's a good point. When you're trying to figure out the numbers that could possibly make this equal 0,
you're only looking
at the two outside numbers, the constant and the leading coefficient. If Tony miscopied this problem, instead of putting a 9, he had put a 19x squared. He'd still have the same possible rational zeros. Oh, well, wait, I got to switch it over.
Okay, so we start off looking at the factors of the constant term. Don't worry about the negative, just factors of 8. Well, what numbers multiply together to give 8? There's 1 and 8, and 2 and 4. 1, 2, 4, 8. Those are all the factors of 8. And then I'll write out the factors of the leading coefficient, 2. Well, that's pretty easy, just
1 times 2.
And instead of writing all those plus minus things, we're going to try to, we take each one of these numbers, put it over 1. I'm just going to draw little arrows. And then we'll put each one of these numbers over 2. So we go plus minus 1 over 1. Notice I'm not showing the 1 over 1 step. Okay, right here. Going straight to the 1 over 1. What am I going to write? 1. Then I move on. 2 over 1 is 2. 4 over 1. 8 over 1. Now, take each one of these numbers
and put them over what? 2. Okay.
So we start off with, I colored the ink. That doesn't. 1 over 2 is just 1 over 2. We can't reduce that. Then we go 2 over 2.
What's 2 over 2? I think we already have it listed. 1. Yeah. What about 4 over 2?
4 over 2.
2. We already have it listed.
8 over 2. 4.
It's already listed.
Oh,
Look
there
at that.
They are.
These are the only numbers that could possibly make that function equal 0. Does negative 17, is it possible that we could plug in negative 17 and this step equals 0? No, it's not in the list.
What about 3?
Do you think we could plug in 3 and it equals 0?
No.
So if you needed to factor this, then take the positive 1. You could use synthetic division. If you get a 0, great. Or you could just take the 1, plug it in. Does that equal 0?
Let's see.
So, then
2 plus 9, 11.
It doesn't.
It does not. No.
Or you could just start going through this list until you find a number that makes that polynomial equal 0. And at that point, use synthetic division to break it down the rest of the way. But all they're asking for here are the possible rational zeros. So let's see which one is it, A, B, C, or D? Hey, the order doesn't matter.
Yeah.
As long as it has all the numbers. I think it's C, isn't it?
Mhm.
1, 2, 4, 8, and what was the fraction? 1/2.
Yeah.
There it is. And what else? What's the
number
next?
10?
Number 10.
We'll do one more of these just to make sure you got the hang of it. Okay.
Find the possible rational zeros. And these possible rational zeros are important because if you needed to factor this, you'd perform this little test to get the numbers that could possibly be zero, start plugging them in until you get one that equals 0, then you can apply synthetic division to break it down the rest of the way.
But that's not something they're going to be required to do.
No. I remember Dr. Kirkendall said that he didn't make him go through the whole process.
Yeah.
He showed them how to factor it when they're given zeros. He showed them how to find possible zeros, but going through the entire
by the way,
process.
these are multiple choice, and there's a downside to the multiple choice. There's no view and example. So I remember years ago a student saying to me, sweetest thing, well, how are we supposed to know how to do it if there's no view and example? And she was right there. And I was like, well, I was sort of hoping that you'd do what I'm showing you right now and putting on the videotape that, do it like that. But, but anyway, factors of 27. What are those factors of 27?
Oh, wait, Tony.
Oh.
Here, okay. Oh, no. I'm going to put that. I don't need that.
You don't need the calculator. Let's see. 1397. Are those all the numbers that multiply together? All that divide evenly into 27. 1 times 27. 3 times 9.
And then the factors of 3. What are those? There's only 2. 1 and 3. And so you take all of these numbers here on top, you put them over 1, and then you take all those numbers on top and put them over 3. Okay.
Now make sure that you're starting with the constant term. If you reversed it, then that's going to give you one of the wrong answers. By that I mean if you put the factors of 3 over the factors of 27. The reason we do the constant first is that's what goes on top. So it's going to be plus minus 1 over 1. Oh.
1 over 1.
3 over 1.
9 over 1. And 27 over 1. Notice how the factors of the constant are always possible rational zeros because you're always going to have a 1 down here as a factor of the leading coefficient. So the numbers you have there on that first row, they're always going to be possible rational zeros.
Now take all of these and put them over 3. So 1 over 3.
That's 1/3. We don't already have that listed. What about 3 over 3? That's 1. We already have it listed.
Then 9 over 3 is
3. We already have that listed. 27 divided by 3. 9. We already have. Look at that. There are only 2, 4, 6, 8, 10 numbers that could possibly be rational zeros.
Mm-hmm. Rational just means they're either the integers or fractions. Okay?
Not something, an irrational number would be something, a square root that can't be reduced, like the square root of 7 or pi.
Or the square root of 3.
Mm-hmm. The square root of 3.
Let's find the multiple choice.
So 1.
Look very carefully at these.
I think
it's no big deal if you miss it on the homework. You can redo it, but on tests, make sure, because these multiple choice ones all look alike. Blur together. Is it A?
A, I think so. Okay. Now I'm going to change up that problem we just did.
Oh, okay.
Yep, I'm going to change it up. Okay, we have a 3x cubed. Instead of a 51x squared, we're going to have a 151x squared. Instead of a 51x, we'll have a 251x.
Does anything change?
No, you don't use those middle terms there to find possible rational zeros. All you use is the constant term and the leading coefficient.
And make sure you're starting with the constant term.
On top. By the starting, he means that's what goes on top. Go back to that one that we just did.
If we had gone the other way, 1 over 1, 3 over 1, we would have gotten the 1/3, 1/9, 1 over 27, and that's going to be listed, the 1/3, 1/9, 1 over 27. The way they got this answer, they put the 3
on
top.
And then the 27 factors.
Okay.
It's the constant term that goes on top. And then the leading coefficient goes on bottom. Any questions there? I haven't taught this stuff in years. I really enjoyed it.
So I'm clicking stop.